this vector field with component functions p and q. All right, so all today we're just working in 2 dimensions. All right, we're just dealing with two-dimensional regions. Well, some of this will generalize to 3 variables later on, like next week or a week after. Now, that means that the integral of f can be written this way. It's the integral of p dx plus q dy. And if you parameterize the curve C, what we would normally do is set up the integral and write it this way, everything being a function of t. Where for x prime of t dt, that is dx, y prime of t dt, that is dy. Okay. So, what we're going to do, instead of doing this approach, we're going to consider these 2 parts separately. So, to handle this part, we're going to view the enclosed region as being of type 1. And for this, we'll use a type 2 perspective. Okay. Of course, in reality, I'm going to be lazy. Just to warn you up front. I'm going to do the type 1 part, show how we handle P, and then I'm going to say that this is similar, and then leave it at that, but in the interest of time. For how many of you is this your last class of the day? Wow, okay. All right.
Plus all the others.
Is today going to be special?
What?
Is today going to be special? Short?
Well, it gives you more reason to not do this, because then there's a chance it might finish early.
Oh, yeah.
And the majority of you would like that.
Wow.
Except for the 2 of you that this will not benefit. I tried.
I still enjoy getting out of class early.
I should probably skip those classes anyway. All right. Now, so we'll take a look at this part, and we'll look at the type 1 version of the region D. So we have vertical boundaries here and here, and curve boundaries here and here. So this is x equals a, x equals b, y is g1 of x, y is g2 of x. All right. Now here's what we have to keep in mind. Positive orientation, counterclockwise. We're going to start on this piece of a curve. We're going to traverse it in this direction, counterclockwise. That's clockwise, isn't it? Yes, it's clockwise. All right.
It always helps to start from the top.
Yeah. I'm doing this for consistency with the notes and book, unfortunately. All right, counterclockwise it is. I'll blame Diana. She can never get her left and right straight. All right. Now, I'm going to call these 4 pieces C1, C2, C3, C4. The curve, not the explosive. And well, so we need to evaluate this line integral of p dx. So it'll be the integral of over C1 plus integral over C2, integral over C3, integral over C4. Okay. Now, fortunately, 2 of these we can eliminate right away, because what we have here is dx, which translates into x prime of t dt. Well, on these 2 pieces, we come up with a parameterization for them. What's x of t, the function x of t, going to look like? So like I need an x of t, I need a y of t.
It's not really.
What?
A horizontal line, this big T equals 1.
Maybe you're just not saying it right, but yeah. So my function x of t is going to be like in this case, for instance. So I need x to be a function of t and y to be a function of t, just describe this vertical line segment.
X is just going to be equal to some constant.
Yes, that's what you were saying, I believe.
Yeah.
Yeah. Okay. So in that case, what's dx?
It's
Zero.
undefined.
0. Yeah.
Yes.
Yeah. Yeah. There's no slope.
Okay.
All right. Yeah. I see what you're saying. But in that case, there is no dy over dx because you'd be dividing by 0.
Okay.
But fortunately, we're not computing that. So in this case, what we have here, dx is equal to 0 on this piece and this piece, because your function x of t, to parameterize that vertical line segment, x prime of t is going to be 0. So we only need to consider the integral over c1 and over c3. All right. Okay. Actually, what I'm going to do, for consistency of the notes in the book, I'm going to make this minus c3 for this one and for c4. Not that we need it anymore. And the reason is, I'm going to parameterize c1 by x is going to be t, y is going to be g1 of t. T runs from a to b. So as t increases from a to b, we trace out the curve c1 and in the proper direction. That's important. Whereas c3, for convenience, I'm going to use the same kind of parameterization, only with g2 of t. And I'm still going to let t run from a to b. So c3 goes in the wrong direction, this way. So I'm going to use minus c3 for the integral to have a right orientation. Yeah.
Would it be much more difficult to go from B to A?
It's cumbersome to write. That's why I did it that way. Yeah. Okay, so C1 and minus C3, but then what we could do is we can change this to C3 as long as we reverse the sign. Okay. All right, now we parameterize both pieces, so now we can fill them in. So it turns out we are going to get something essentially like this. So we're going to have, so for C1, my parameter runs from A to B, and then I'm going to have P of T, G1 of T, and then X prime is just going to be 1. Minus the integral over C3. Again, T runs from A to B. We'll have P of T, G2 of T, again, times 1. Okay. All right, so
Where did you get the 1 from? For DT?
So for both these pieces, x is just equal to t,
Okay.
so dxdt is just 1.
Right.
All right. So let's combine these into a single integral, since the limits are the same. Now, for convenience of what's going to come later, I'm going to pull a minus outside, because I want to list G2 first. Then minus P of T, G1 of T. Okay. All right. Now, I'm going to go backwards in a way. I'm going to take this difference